Hey everybody, it's Miss Eisencraft. I'm back with the second part of the review. So in week 10 and 11, we did graphing sine and cosine, um, or sine and cosine graphs. And like any family of functions, sine and cosine are a family of functions, and you have the parent function. So what I did here is I went ahead and just imported a graph of the parent function y equals sine of x. And then we'll kind of look at, okay, what are some different transformations that could happen and where would they show up in the equation? So y equals sine of x, what's happening here is the x values are actually the, angles. And we have them marked here in radians. So we're looking as you go around the unit circle to these angles, what is the sine value? And if you remember, the sine value is the y coordinate, right? So when you start at 0, the sine of 0 is 0. Then the next stop we have on our unit circle anyhow is pi 6, or 30 degrees, and the sine of that is 1/2. So we don't normally, when we're graphing these, we don't usually have you graph those. I think Miss Moret showed you those. Pi 6 is right there at 1/2. Then pi fourths is at, sine of pi fourths is root 2 over 2. And root 2 over 2 approximates to about 0.71 or something. And then sine of pi thirds is root 3 over 2, which approximates to 0.866. Okay, well, that's like super annoying. Who wants to graph those or even figure out where they are? So the nice thing is sine of pi halves, sine of pi, sine of 3 pi halves, and sine of 2 pi are all nice numbers. 0, 1, back to 0, then to -1, then back to 0. But it's important to know it makes a curve. So that's why I put these there just to show you that these, aren't a straight line. They make this curve, and all the tweener degrees or radians as well would fall on this and make a smooth curve. So it's important to know that while we plot just these points, it's not a V shape. It's a curved shape, okay? So this is the parent function of the sine graph. It repeats the cycle. And so we often ask you to make 2 full cycles of the graph, but we're really looking the unit circles from here to here, and then we're just repeating it. Okay, so some things that are helpful to look at when you're looking at the sine graph to either make an equation or to write an equation or to actually graph it is a midline. So you're going to need to know that the midline is the line that cuts the graph in half vertically, okay? And in the parent function, it's right on the x-axis or at y equals 0. So you're going to need to know that just the name of that. This is the midline, and it shows up in the transformations as well. It helps you determine the transformations. Then something else you need to know is something called the amplitude. So the amplitude is measured from the midline. It is the distance from the midline to the maximum, or from the midline to the minimum, right? The absolute value. So that is called the amplitude. And in the parent function, it is 1. Okay. And then another thing you need to know is the period. The period is how long it takes to make a full cycle. And because it repeats itself, it can look a little confusing. So I always like to measure from 0. And I ask, how long does it take to make a full cycle? It looks like all the way to 2 pi. Okay. So something else to know, if that's period, if it takes more or less, the frequency changes, meaning it's repeating the cycle more quickly or more slowly. Anyway, so if we're looking at the graph here, the equation here, A is the amplitude. So if you notice that the amplitude is more than 1 or less than 1, you would put that here. So this right here is the amplitude, and that can be measured from the midline. Okay, the K value is if it shifted up or down. So there is If it's at the x-axis, you just leave it there. But if it went up or down at all, then you put it at the end. So this can be measured by the midline. So this is the up or the down, and it is the midline. Okay. If it goes right or left, we call that a phase shift, and that's this right here. And because this repeats itself, any of the graphs, you could say they shifted left or right. But I typically always just, to make it simpler, just say, okay, I just always look to the right. Then we have this extra piece, this B value. This B value is called the frequency. And the frequency is, let me just write this in. The frequency is how many times does it go through the cycle between 0 and 2 pi. But there is a calculation. The frequency is a number that you will get, and how you get it is you take 2 pi divided by the period. And so the period, that was this here, the period was 2 pi. So 2 pi divided by 2 pi for this one in particular, the parent function was just 1. But if it would have, if the period would have been just pi, let's say it did the cycle right here, it completed the cycle by the time it got to pi, you'd have taken 2 pi divided by pi, and you would have gotten 2 as the frequency, which means it will have 2 cycles by the time it gets to 2 pi. But this is the simple calculation. The frequency is 2 pi divided by the period. The period is the length of time it takes to make a full cycle. Okay, so that's how you either write equations or you graph from there. Okay, cosine is a little bit different. You're still using the unit circle, but it starts at a different place. I always like to think it starts at the top of the hill. So the cosine of 0 is 1, and then you're going around, and then when you get to pi halves, the cosine is 0. Then you're getting to -1, then you're getting to 0, and then you're getting back to 1. Okay, so you start up here, and I also put those in between points to show you it's not a V, it's a smooth curve, right? That's what would happen here. So the same thing is true. Cosine, just make sure you know it starts up there at 1, and then at pi halves it goes to 0, then -1, then 0. And again, if there's an amplitude change, you don't necessarily need to say 0, but you could say back to its midline, and then its minimum or its maximum. So, but the parent function, this is what it looks like. Again, I always like to think it starts at the top of the hill. And again, the amplitude is this number out front. The amplitude is A. And in the parent function, the amplitude is just 1, right? The midline of the parent function is also at 0. So it's the midline, but that's if it goes up or down. You would determine that by the midline, okay? The B is the frequency, and if you look here, you can measure the cycle from anywhere, but I like to measure from 0. So for, again, the period, if we're at the top of the mountain, when again are we at the top of the mountain? Boop, at 2 pi. So the period of this guy is also 2 pi, okay? So the frequency, if we calculated the frequency of this guy, we would say the frequency is always 2 pi divided by the period, which was 2 pi, which would be 1. So that's the period. Okay. So we would not need to put another number there. And then the phase shift is if, I like to look at this point, okay, if it's a cosine graph, does it start over here somewhere? Does it start over here somewhere? Right? If it does, then that means it has a phase shift or a translation right or left. So let's go ahead and write phase shift. right or left. I always look to the right. And then this right here is called the frequency, which can be calculated. All right. Have fun on the massive Delta Math assignment and be thankful there's no final. All right. Bye bye.